Okay, so that was dynamic range. We need to know about frequency response. Okay, we need to see how it responds to receiving sound waves, not just a straight line like I showed you earlier. It's going to look more like this. And what we're looking for is that straight line. We're looking for the flattest and widest frequency response possible. Okay, and we're starting at 20 hertz. We're going to 20,000 hertz. And here, this is a really good frequency response. This is about as flat as you're ever going to see. Okay, as one kind of random example here. Some microphones are biased. I mean, they have strong opinions. I mean, they have certain treatment that they electronically have kind of induced here, I guess you'd call it. And so this is good for, like, this microphone would be good for vocal recording. It's really giving the speech pattern, the speech frequencies a boost. Now, I mentioned that you already have a boost with speech frequencies with the equal loudness contour going on in your ears, but this is just going to just amplify it even more. And this is a vocal mic may have this sort of bias, and it's got, you have to look for this in the frequency response. And oftentimes, if you go to one of these, online music stores, you'll find a graphic that has the frequency response listed, okay, and dynamic range and other parameters there. Here's one for a kick drum microphone or a drum set, and that's amplifying the low, ultra low frequency of dun, 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 right, from like 100 hertz to 1,000 maybe. And lastly, pickup patterns. There are a lot of other kind of parameters that we can look at that qualities of a mic that would help us make a decision, but these are the three main ones. So pickup patterns, otherwise known as directionality. Now, if you're holding a mic and say, you're kind of holding it upright here, and I'm looking around the microphone, if I'm right in front of the mic, I'll say I'm at 0 degrees. All right, directionality is the area around the mic's head, or what we call the axis, that can pick up sound waves. All right, all the way around from 0 to 90, 180, 270, and back. We don't say 360, we just say 0, back to 0 in this case. All right. If I'm in front of the mic, as I mentioned before, where the diaphragm is, where I'm recording, is the axis. So you want to be on axis as much as possible in your recording. All right. If you're directly behind, so let's say it's a dynamic microphone, you got to be right on top of that thing to get a good signal. It's rejecting everything else. If I'm behind it, I am 180 degrees off axis, and that'll be the most possible microphone rejection, signal rejection. Okay. So we use this 360 graph called a polar pattern. I just described this as kind of like a little more, I suppose, informal way. A more formal way to describe the mic qualities here for directionality is a polar pattern. All right. And you see, this is like the Rebel Alliance or something, right? This is a polar pattern for a dynamic microphone. And what I'm looking at here is this upside down heart. If it was, imagine it's just colored in red for a second. That is the entire kind of sweet spot, if you will, of the microphone's signal. The axis is here, but everything that we can possibly record is really going to happen right here. And behind it, all this is going to really almost immediately become rejected, being off axis. And that'd be like a dynamic mic. All right. And it's called a cardioid pattern. Cardioid meaning heart. This is like an upside down heart pattern. All right. It picks up sound from the front of the mic best and intentionally rejects it from the away from the front. Another type is called a hypercardioid. All right. This is used when you need a little more range around the mic, right? Keep a little distance away. There's another type called a supercardioid pattern, also known as a shotgun mic. It looks like a very long, kind of slender microphone. Sometimes you'll see this for if you're watching like a football game or something. They'll have somebody holding a long mic boom arm, and they'll have this telescopic, what's called a supercardioid mic, a shotgun mic, and it's really zoning in on a particular voice. It's like a very narrow axis here. All right, so you can use that for like wildlife, for recording the tweet of a bird in a tree, or like, you want to get some voices in a medieval or Renaissance battle or something like that, medieval battle simulation, all these types of things. And it's great for recording location sound effects and really honing in on a particular signal or sound that's being generated. Another type of mic is called a bidirectional, or more known as a figure-8 mic. This figure-8 pattern has axes on two sides, on the 0 and the 180 side. Okay, and I'm looking up in the air. It's like a bird's eye view of the microphone. Oh my God, please don't don't go to the bathroom, Mike. 0 degrees here and 180 here. There's the axis here and here. Okay, and why would I need that? Well, if you were recording an interview, you would want to talk into the mic, and then sometimes you see reporters that say, "What are your thoughts on that?" And they take the mic, and they immediately, they're still talking, and they move it over to the person they're interviewing, and you can't hear them anymore, or they don't go fast enough, and you can't get the first words that the person is saying. That's because there's only one axis, and they're moving it around quickly. If you have a figure-8 mic, you don't need to move it at all. You can just hold the mic in place. There's one axis here, there's one axis here, and you're done. Okay, it's great also for recording kind of like a nice performance from two voice artists. If you have like a Sam & Max game, for example, Sam & Max may be recorded at the same time for certain scenes to keep that nice pacing and delivery, so we don't have to manually take two raw sound files and kind of like fake the choreography. We can get the live performance of the two, a figure-8 mic. Okay, and some of those microphones can be stereo, so that they have two independent signals running, and they end up on two different tracks in my computer while I'm recording them. The most, I guess, versatile mic would be the omnidirectional mic. Everything, the whole thing's on axis, all of it at the same time. So this is great if you want to record a band for your next game and you only have enough of a budget for one microphone. Get an omnidirectional, because you can just stick it in the middle of the room and it's going to record everybody at the same volume. Okay, or if like you're in the middle of a crowd recording crowd sound effects, you can have an omni mic, and so what you can do is just kind of hold it anywhere you want, maybe above the crowd, and you'll get everybody at the same time if you're in the middle of the crowd, which is very useful. And a lot of mics now you see, especially some of the USB mics and other ones, you might pay a little bit more for this feature, but you can get multiple directionality settings. So you can have the cardio, you can have the hyper and super, or you can have figure-8 and omni. Okay, some of the better quality mics will give you multiple pickup patterns, multiple directionality. As I mentioned earlier briefly, there are plosives, and I did not mention sibilants yet, but plosives are when we're talking into a mic and you use those heavy P and B sounds. And sometimes you may be listening to a recording or something, you hear this like very boomy sounds sometimes with the consonants. It's often the P's and B's that we record. And what's happening is it's just tremendous air pressure generated on those. And you can test it with a piece of paper in front of your mouth. You can just try rattling off some words or consonants and try, please pass the peppers, and you'll see that you'll make the paper move really forcefully with those plosives. On the other hand, there's sibilants too, and some people that speak into a mic have these kind of high frequency S sounds that are just, they seem much louder than the other vowels and consonants that they're generating, and you may only hear this when you're recording into a microphone. A way to eliminate these two problems is with a pop filter, and this is that double pane again. Once again, so there's a layer of material, there's some air in between, and another layer of material, just like cloth, basically high density cloth. And so when you speak and you hit that plosive, it vibrates the first layer of cloth. That it kind of dies in the middle with that air pocket, and by the time it gets to the second layer, it's just a little vibration, if any at all, and your mic is spared the force of those plosives, and kind of there's a little bit of occlusion going on too, so you're losing some of the high frequency sounds as well. And a pop filter you can get for like $20, and you see them a lot in videos of people singing, and that's why they have them. By the way, most mics are mono, but as I mentioned earlier, sometimes you will get a stereo mic that you can use in different applications, different pickup patterns. Oftentimes, you'll see them that look like these little pocket recorders here. Some mics will even have surround capability, or as I mentioned, there'll be ambisonic microphones that can record all around them. All right, many different types of mics out there, but the most common mic you'll get in the studio is mono. The most common you'll see someone with, or if you're doing it yourself in the field, doing some outdoor recording or location recording, you might have a stereo mic.